Hello, and thank you for joining this session to talk about pathways for decarbonising steel production. My name is Marian, and I'm the Global Head of Risk and Sustainability at Liberty Steel Group. For those of you who don't know Liberty, you can think of us almost as an industrial startup, having brought the group together in just under 10 years with our first acquisition in 2013 of a small rolling mill in the UK. We've built scale over the past 5 years through well-timed counter-cyclical acquisitions, which are now bearing fruit. And today we have over 30,000 employees worldwide, a presence in 12 countries, and annual revenues of around $16 billion last year. Around half of our global production is through major primary production hubs in Australia, the Czech Republic, and in Romania. The other half is from EAFs situated in the UK, USA, Poland, and Australia. We also have various downstream operations across our global portfolio. In 2021, our total carbon footprint was around 16 million tonnes per annum, and our carbon intensity was around 1.7 tonnes of CO2 per tonne of steel produced. So, like all steel producers, we have a large task in front of us to decarbonize our operations. We have around 20 minutes together today, and we'll talk about 4 things. Why the UK needs to transition to low emission steel production, how we can decarbonize steel production. I'll talk through the potential decarbonisation streams and then spend some time on the ones that we've chosen and illustrate how we're planning to implement our decarbonisation plans. We'll look at what the hurdles and enablers look like, as well as the timescales within which we need to implement the transition. And finally, we'll tackle the elephant in the room that not enough people talk about. Let's dive in. Why decarbonise? So we all understand the mission, right? As a world, we need to halve emissions this decade and get to net zero emissions by 2050 if we are to limit global warming to 1.5 degrees above pre-industrial levels. This transition, though, poses unique challenges for the steel industry. Today, steel and aluminium production accounts for over 10% of global CO2 emissions. Steel, as many of you will know, is the world's most used metal. Today, we make over 200 kilograms of liquid steel each year for every person on the planet. So could we just make less steel or recycle more to meet demand? So we can certainly increase the use of recycled steel and improve manufacturing processes, but the reality is that as developing nations industrialize and middle classes expand, and as we use steel for cities of the future, wind turbines, electric cars, the need for these foundation materials will continue to grow rapidly. By 2050, the demand for steel is projected to double from 2012 levels. So if we are to get to a net zero world, and as you'll see on the slide, many countries are already legislating to be carbon neutral by 2050, there is no way that we can accommodate this industry doubling in size without fundamental change. But decarbonising steel production is not only about contributing to the transition to a net zero world. We see the transformation of steel production as a real opportunity to develop the industry yet again into an engine for growth that will continue to sustain vibrant industrial communities worldwide. First movers in the reinvention of our sectors will have a significant advantage. Those who innovate will gain market share by meeting demands for cleaner steel, will attract the best talent, and will build the skills needed for these new production techniques. In the UK, steel accounts for 15% of industrial emissions, and so facilitating a pathway to decarbonisation will help to meet the decarbonisation targets set by government. The steel sector also provides really well-paid jobs in industrial heartlands, paying around 33% more than median salary and supporting 42,000 indirect jobs in the wider UK economy. These well-paying jobs are also primarily located in less economically advantaged areas. So future-proofing the steel industry plays really well into the government's levelling up ambition. And the domestic demand for steel is forecast to grow. The UK steel industry looks to become around 6 billion by 2030, much of which will need to be satisfied through low carbon emitting production techniques. So being part of this transition is in many ways a no-brainer for both policymakers and industry participants. That said, it isn't straightforward. So let's look at the various pathways producers can follow to decarbonize before we consider the challenges and enablers that they will need to facilitate this transition. As you'll see on this slide, around 79% of UK steel production is through the blast furnace to basic oxygen furnace route, which emits around 2 tonnes of CO2 per tonne of crude steel produced. EAF, electric arc furnace production in the UK, accounts for 21% of crude steel made and emits between 0.6 to 0.9 tonnes of CO2 per tonne of steel produced based on the current emissions intensity of the grid. So actually, as a first step, simply shifting this mix towards a higher proportion of EAF production will greatly reduce carbon emissions from steel production in the UK. At the next level down on this chart, we then look at ways in which producers are thinking about reducing emissions from both blast furnace and EAF production. Many of the options around decarbonising the blast furnace production are either limited in terms of their carbon reduction capability, as you'll see at the bottom, or where they do have the option of reducing carbon emissions to near zero, they're really still in their infancy, like carbon capture and storage or biomass. And so we see the future of steel production moving towards the right of this chart, with a higher volume produced from scrap in EAFs or through the direct reduction route, either using natural gas or hydrogen as the reductant fuel. Reducing the carbon intensity of the electricity in the EAF process and moving towards green hydrogen as the reductant fuel in direct reduction processes will bring emissions down close to zero. For Liberty Steel Group, we've set out 2 major pathways depending on local market dynamics. So in mature markets, such as the UK and the US, it makes sense to utilise the growing arisings of scrap available locally. Our strategy in these markets is to optimise the available scrap and increasingly power our industrial processes with renewable energy. Although, as we talked about, with the growing demand for steel, there's not enough scrap to satisfy global demand. So as a global group, we have to have a route to decarbonise primary production. And that's where breakthrough technology needs to be developed and applied. So how are we going to do that? I'll use our site in Ostrava as an example of how we are decarbonising primary production. And really, this lays the platform for breakthrough technologies such as hydrogen, which can benefit wider industry and their decarbonisation efforts. So at Ostrava, based in the Czech Republic, our green steel transformation plan is based on recycling the massive amounts of scrap available in the Czech Republic and Central Europe. In July this year, we signed a contract with Danieli, who is a global manufacturer of plant and machinery, for the delivery of 2 state-of-the-art hybrid electric arc furnaces, which will be at the centre of Ostrava's plan. The new furnaces are actually the first of their kind in Europe, and they'll have a combined capacity of 3.5 million tonnes per annum. This will serve to reduce the overall CO2 emissions of the Ostrava steelworks by more than 80% by 2027. These 2 200-tonne furnaces are expected to be operational in a couple of years. So by 2025, they should be fully operational and will be able to melt 100% scrap by 2027. And then as we move further to the right of this chart, full carbon neutrality is then achieved once the plant is transitioned to using 100% scrap or green direct reduced iron using green hydrogen to fuel its reheating furnaces and capturing the CO2 from its primary units, will then offset the residual carbon production. We have similar plans in place for our primary production in Romania, and another great example of our strategy in action is the plant at Whyalla in South Australia. Now, Whyalla is set to become the world's first steelmaker to integrate a hydrogen pilot plant into its continuous steelmaking operations. And we're really lucky in Whyalla because that location enjoys ideal conditions for green steel production, which includes vast magnetite iron ore reserves, abundant solar and onshore wind energy, a deep sea port, and a really skilled workforce. So fantastic conditions there in Whyalla for us to really transform the steelmaking process. Also, South Australia has just elected a very forward-thinking premier who's committed to building a 250 megawatt hydrogen production plant in Whyalla by 2025. So that massively supports our plans for hydrogen steelmaking at our steel plant. And then what about the residual emissions? So whilst we're absolutely committed to reducing emissions to the lowest possible level, there will always be residual carbon from our operations. So in order to deal with this small volume of residual emissions, we will also need to investigate and invest in new approaches such as effective land management to capture and sequester carbon. Now, we've already started putting some of that into action, and an example of this is at Jahama Highland Estate in Scotland, where we're leading in the restoration and management of peatland. Jahama is a multi-enterprise rural business extending over 114,000 acres of Loch Arbour in the Scottish Highlands. It produces two important carbon stores. It's got woodland and peatland. Now, peatland is actually the most efficient terrestrial carbon store. It holds around 100 kilograms of carbon per cubic meter. It grows infinitely and in perpetuity, and Jahama has already restored almost 100 hectares of peat. So our plans are well underway, and we're confident that the transition can be achieved. But we're not naive enough to think that we can do this all on our own, or that there aren't major hurdles and challenges that we need to solve as an industry in order to achieve decarbonisation at vast scale. We see 5 key enabling factors that are vital to the transition to green steel, and I'll talk through some of them now. The first you'll see in green on this slide is a supportive policy environment. Now, when we think about policy, it's a really fine balance in looking at incentives and regulations, where if the policy is implemented too strict, too quickly, there is a real risk of undermining competitiveness and reducing the funds available to invest in the transition. But without any incentivization or regulation, the industry won't move quickly enough. So policy incentives are therefore required to support the industry and are really important. In the UK, this looks like effective border adjustment mechanisms, which will protect low carbon emitting domestic producers. And also we'd love to see reforms of the UK ETS, which deal with uneven free allowance allocations. In black, you'll see supply. So as I mentioned earlier in the presentation, abundant, secure and cheap renewable energy is required. A transition to EAF production will require a 4-fold increase in electricity usage by the steel sector. And I'm sure I don't need to tell anyone about soaring electricity costs. Without a move away from the marginal pricing basis in the UK or support for industrials around energy prices, steelmakers will struggle to fund current production, never mind transition to low-emitting processes. We recently worked with Green Alliance to produce a report into what would be needed to support the transition in the UK, and they found that electricity prices would need to be set around £50 per megawatt hour to improve the attractiveness of steel decarbonisation and make scrap through electric arc furnace investment a more sound financial choice compared to relining an existing blast furnace. We're quite some way from £50 per megawatt hour, so huge work needed there on energy prices. Still on the supply side, scrap will increasingly become a precious commodity, and high quality iron ore for direct reduced iron production will be key. In that respect, we believe primary production will gravitate towards geographies like Whyalla that I talked about that are best placed to supply these inputs competitively. In the UK, limited availability of high quality scrap steel is a major barrier. The UK generates more than 11 million tonnes of scrap each year, but most of it is unfortunately poor quality and is exported overseas. So what can be done about that? Some of the things we think around are VAT exemptions on scrap steel sold in the UK, capital allowances for equipment related to scrap processing, and also minimum quality standards, which would help to improve the quality and security of supply in the domestic scrap market. And then what about demand? So demand for green steel is still low across steel consuming sectors, but growing particularly in the automotive and public sector procurement areas. We think that demand will increase quickly as green steel becomes available, and that will attract a premium. And we're already seeing public procurement moving in that direction, which will be very positive for those steel makers who are transitioning more quickly. And then what about finance? So there's no getting away from it. The transition to low carbon emitting technologies will be expensive. According to the Net Zero Steel Initiative, the sector will need more than $36 billion investment annually in capex to meet the high demand in the future and transition to low carbon technologies. Clearly, steel companies on their own can't make all this investment and will require support from government, both in terms of policy and direct investment, that will benefit from a decarbonised steel sector. So again, working with Green Alliance in the UK, they, along with the Materials Processing Institute, have previously suggested that support for hydrogen production plants could be provided through the Green Steel Fund that was recently announced a few years back. Now, their estimates are that financing for a pilot all the way to demonstration phase in an electric arc furnace for hydrogen production would run to around £140 million, which would easily be covered by the Clean Steel Fund. Using hydrogen for steelmaking or other processes downstream will require the government also to deliver on the 10 gigawatt hydrogen capacity target that they set for 2030. And finally, human resources, the most important resource of them all. The demographics of the global steel industry, particularly in the West, are against us, with an aging workforce and fewer people who are younger seeking the steel industry as a sector of choice. At Liberty, around 20% of our workforce is over 55. So there's a real need for a concerted effort across the sector to revitalise the image of steel as a force for good and a place where young steelmakers can genuinely influence the transformation of a fundamentally important industry. And when do we need this all by? So the blast furnaces that we've talked about that produce the bulk of the sector's emissions need relining every 20 years at a cost of hundreds of millions of dollars, up to $500 million. So if you invest in a blast furnace today, the likelihood is that you're committing to 20 years of those emissions, and we won't get the emission reductions we need to align with a 1.5 degree world. So these long investment cycles mean that many of the technologies and transformation projects that are needed to achieve net zero have to be in place by 2030. We are out of time. By 2030, we must see entire value chains committing to and transitioning towards net zero, along with the systems in place to reliably track progress against these commitments. And that's why we've set ourselves one of the most ambitious targets in the industry, to transition our existing sites to carbon neutral by 2030. And I promised you an elephant. So what's the elephant in the room? As we transition to a low carbon economy, implementation of new technologies and retiring carbon intensive processes will have a huge impact on the communities in which heavy emitting industries operate. Managing the human element is a complex problem. We will see a change in the skills required in industry. We will see lower manpower requirements and potentially more expensive end products as a green premium is applied during the transition. Our employees are a vital part of steelmaking, and we need to make this a just transition, bringing our existing people with us while encouraging younger people to help us transform. So that's why we've launched a Green Steel Academy to upskill our current employees and also to inspire future generations. We really firmly do believe that by transforming the steel industry, we can provide quality jobs for generations to come and modernize industrial sites and communities that have been neglected in recent times. Our Green Steel Academy and really exciting partnerships with local universities and communities supports the training and recruitment of this next generation of steelmakers. We also think that the increased output of our operations as a result of this transition and the increase in demand will result in a greater variety of jobs, helping to change the image of the steel industry that we talked about and creating opportunities for a range of new skills to be deployed within our business. So thank you for listening. I'm conscious we've covered a great deal, and I hope that that has been useful.